Hi everyone! The aim of this lecture is to show how a full model of Industry 4.0 could be implemented in fashion and which design principles can support this transition. After this lecture, you will be able to understand the implication of this model for the design process. The potential of digitization processes coming from all sets of 4.0 technologies produces impacts which overcome boundaries of factories. In fact, their added value no longer sits, as in the previous Industrial Revolution, in an enhanced capacity of calculation, but in the possibility to connect virtual and physical realities with the Internet of People and Internet of Things, and furthermore to replicate for the first time in human history cognitive processes with the artificial intelligence, AI. In light of this scenario, it is clear the need for a further systemic approach to digitization, which should include, around the smart factory, the entire ecosystem linked with it. The way we can look at the 4.0 concept today should overcome a manufacturing-centered vision to embrace a combination of smart factories, smart networks, and smart products. This tripolar model integrates in each sphere all main processes of fashion cycle. Therefore, the smart factory pole includes production and logistics, the network sphere includes supply chain management, retail and communication. The products sphere includes products development, prototyping and sampling, and finally, research and design, centrally positioned, function as the ideal connection among the three components. The model also reports a set of technologies and applications supporting 4.0 model implementation. In each sphere of the scheme, you can find examples of technologies in enabling 4.0 innovation, but as their nature is mainly open and multipurpose, almost all of them can find application in any sphere. The industrial innovation expert Mario Hermann, Tobias Pentek, and Otto Boris identify 6 design principles to drive the full implementation of 4.0 industry model: virtualization, decentralization, interoperability, modularity, service orientation, and real-time capability. Let's look into them, making some examples within fashion showing their implication and innovation potential for the design process. The first principle is virtualization. It means that all processes within the 3 spheres are completely virtualized, whether they are digital or happen in the physical world. This implies that there is a virtual copy, always updated, of the fashion creation, manufacturing and distribution cycle. There are several tech solutions which allow virtualization, as for example all types of sensors, from the environmental ones applied to factories to RFID embedded into products. Among the many benefits of this approach, one is particularly important given contemporary consumers' attitudes: the possibility to reach a level of radical transparency. Having acknowledged the many negative social and environmental impacts of fashion, as well as understanding the extensive use of individual data brands have been making for commercial purpose, people are now claiming back transparency and rewarding those brands who are able to track their product all along the entire cycle, such as, for example, Everlane, a fashion house founded in 2010 upon this principle. The second principle is decentralization. It means the creation of a flexible distributed supply chain network based on the capacity, for example, to adapt to local market variations. The principle can be applied to the whole value chain, including not only manufacturing suppliers, but also the retail network, merging physical and digital channels. Decentralization can be enabled by several tech solutions, such as, for example, digitized manufacturing, CAD/CAM, 3D modeling and printing, for example, as well as supply chain management information system, enterprise resource planning, ERP, and product lifecycle management, PLM. Among the many benefits of this approach, a model for distributed manufacturing is certainly a very promising one. This would imply the implementation of interconnected light manufacturing nodes, empowered by real-time information exchange and globally spread to be as close as possible to final markets. This could dramatically reduce costs and impacts of logistics, rely on locally based sourcing, manufacturing, retail systems, directly linked to the design headquarters. If traditional fashion brands are slow to embrace this concept, design-driven makers culture and Fab Labs networks are pushing towards this direction. The third principle is interoperability. It is the characteristic of a product or system to work and interact with other products or systems without any restrictions, where humans enter as an interface within a hybrid cyber-physical model. This can be easily allowed by the integration of the IoT and IoP technologies. Within fashion collection development, hybridizing craft techniques and touches with advanced technologies represents a powerful strategy of differentiation and a very interesting trajectory for future job evolution and development. Several examples are already showing the potential of this paradigm, redesigning factories as open cyber-physical ecosystem, where augmented individuals can become 4.0 craftsmen, opening an unexplored spectrum of possibilities to design. The fourth principle is modularity. It is intended as a system designed through modular subsystem and components, able to flexibly adapt to changing requirements by replacing or expanding single modules. Therefore, modular system can be easily adjusted in case of seasonal fluctuations or variation in product characteristics. This principle brings several benefits in terms of flexibility and efficiency within manufacturing, but can also be applied to the way brands conceive their collections and products, overcoming traditional concepts such as seasonality or even size and gender. The shoes brand ACBC represents a very interesting example of this kind, showing the potential of modularity as a design principle and its beneficial impacts also from a sustainability standpoint. The fifth principle is service orientation. It is intended as a diffused approach within the whole network of the company, where any function, business unit and touchpoint between them or across the company borders is conceived as a service. Several different network systems, interfaces and dashboards can allow all internal organization participants and external stakeholders to easily access services with greater benefits in communication and efficiencies. Given the consumer's shift from a passive reception of brands' communication to an active interaction with brands and other consumer communities, service orientation can open a new business scenario for fashion. From being a product-centered system, fashion could finally embrace the service economy paradigm and possibly more advanced ones, such as the sharing economy. Cases such as Vestiaire Collective and Dress You Can, among many others, are already showing this trajectory. The sixth principle is real-time capability. It is the result of a fully virtualized product's lifecycle management and requires that data is collected and analyzed in real time, informing all processes. Real-time capability does not imply only a continuous and real-time flow of data, but the capacity of analyzing and synthesizing them to make them available to different functions in a form that can enable decision-making and reaction in real time. This can be allowed by fully integrated EPR and PLM systems connecting all processes: design, product development, manufacturing, retailing, and possibly product dissemination. The implications of real-time capability have already been foreseen 3 decades ago in the so-called model of mass customization. Today, real-time interaction with users and e-commerce can finally allow on-demand customized production to happen, with the benefit of disintermediation between brands and consumers. This represents a real chance for design to be directly informed by users' demand and to move on designing no longer products but platforms, enabling users to co-create their own products. The digital native brand Velasca implemented this direct brand-to-consumer model, demonstrating the possibility to offer high-quality products at an affordable price, cutting out intermediation costs. The 4.0 paradigm and the potential of digital technologies integrated with the physical resources is opening up to design a crucial dilemma. As underlined before, these technologies are not only able to speed processes, but to autonomously learn and take decisions. Would this imply that we will be able to design through algorithms? With system processing data and learning how to design from them? Cases such as Stitch Fix seem to go this direction. But as Zoe Broach, fashion innovator and head of fashion at London Royal College of Art, has pointed out, platforms designing through AI seems to imply a progressive homologation in products. They are replicating basic human chemistry by processing and reducing to algorithms consumer behaviors coming from the platform itself, while leaving very few room for alternative creativity. That's the reason why we do believe that design thinking, fueled and empowered with AI insights, should return back at the very center of the model, keeping our imagination alive while being real-time informed about impacts, actions, and reactions of the surrounding cyber-physical ecosystem. In conclusion, during this lecture you have seen how to shape Industry 4.0 paradigm in fashion and the specific potential this can bring to design as a process.